Hello everyone. Today we're going to do another revisit. Um, this time would be chars and strings. 'Cause last time we have done the revisiting for the loop ideas, and many of students gave us feedback that they learned more through examples. It will be more intuitive for them comparing to that of the lecture. So that's the reason we're doing it today for the strings there. So let's get it started. Um, so let's revisit a little bit about the chars and the strings. And actually, we have mentioned in the lecture that a computer only recognizes numbers. There's no characters actually stored directly in a memory. So what's happening in between is and there when the main function is calling the printf there, and the printf receive that percentage C, and based on that he knows that he's going to print a character on this screen rather than a number or the other stuff. To do that, he is going to check out the mapping table, which in which every character actually has been associated to a number there. For example, here the 3 is the character for the heart shape, and there are others there, diamond, there, so on and so forth. So once you give a number, the printf is going to check this number. For example, here we have a punch card in the workspace or in the memory. It's a number 11, and in that case printf is going to look at the mapping table here. 11 has been associated to this character. In that case, this character will be displayed on the screen rather than the number itself. So this is what the printf with the format tag of percentage %C is doing. Okay, this is actually the mapping table. It's called ASCII. You will see that the number from 0 to 255, each of them has been associated with a character there, and you could basically checking out this table and to understand which character will be printed out. Indeed, in the lecture we haven't introduced, there are basically 2 sessions about this ASCII table, and the range from 0 to 127 is called a standard ASCII. That means it's a class system, and all the systems are using this mapping table. However, there are from a range as shown here, 128 to 255. It's called extended ASCII table. For that, association between numbers and the characters might change, depends on the system. So that's called extended. However, what we're using here is the code page 437, and you can, in different system, you can switch between code pages, and that's the reason in one of the lectures we mentioned you can actually switch the code page in your Windows system or Mac system by using different tricks. Okay, anyway, in Windows you can switch to code page for 37 by use the command chcp space, and then for 37 to switch to this coding table. In that case, for each of the numbers, it will be associated to the characters shown here. Okay, so that's it. That's mapping table. With the mapping table, we can actually play with chars. You will see that, as I mentioned, there are only numbers there. There's no character. In that case, we can play the chars with the number directly. For example, let's check it out. This 14 is an interesting character. It's that music icon, so I can just use this music, and I can also use the percentage %C printing out the 16. It's if you check the mapping table here, it's the button for play, the icon for playing music. You see a lot somewhere else. So if we run this, you will see that the first character is the music icon, the second is the playing music icon. Okay, you will see from this example you can actually play using the number directly, because the number is what the printf is checking. Let's play more. In that case, I have prepared an example here, and you can actually do this by continue playing this. Let's do it. And we are picking up more numbers. For example, we are using 10. 10 is actually is the value for start a new line. That's exactly you can do the same by assign this \n. It's the same. It will give you the same character. So by printing out 10 as a character, it will start a new line. Okay, we can copy this and putting other numbers there, and this will make it faster. And this 201, and I can do more. Okay, so you will see that according to that one, and going to give it 205. So I'll tell you what those numbers are later. Actually, why not I just note the example I have prepared previously rather than typing them again. So I'm going to, this is probably it. That's it. No, okay, forget about it. Let me just do it. So you will see that doing in this way, there are a lot of work to do, because you have to do it a lot of typing. Sometimes it's complicated. It's just a tedious work. Okay, let me finish. Let me copy this in one 32. and 67 and 32 and 186 and another. Okay, to start a new line, and let me finish the last one. It's going to be 200 205 205 and 180. Okay, done with the typing. A lot of them I don't like it doing it this way. However, I think by doing it, it will help you to understand these charts better. Right now you will see that what we're going to have is the music icon and the play icon, and also we have a square and with a C. So what happening is, if you are checking why we are having this result, by going back to the ASCII table, you will see that 201 here will be, it's here, it's a top left color of a table you have seen actually, and the 205 will be border. It's a horizontal part of that border, so we keep printing the border of the table, and it's going to give us a line, double line as a boundary for a table. And then 187 is the 187 as a top right corner of it. Then we use the backslash m, or that means the start new line, to start the drawing of the second row of that table. Okay, then in that case we're going to start a new line of the table at the second row, and 186, if you're checking it, it's going to give a vertical border of that table. And we use the 32, which will give us a space here. If you are checking in the table here, you will see that 32 is a space, so it's going to give us a space. Then the 67, it's going to give us uppercase C there inside that table, the second row of that table. Okay, then by checking them back one by one, you will see what's happening. However, there's an easier way to do it. We can use the debugging to see what's happening there in between. And let me just enlarge the font, you will see it better. Okay, right now the code stopped here. Let me move to next line. It's going to see it. It's printing out a music icon. Then I go the second and the play icon, and right now it starts a new line. Actually the current position of printf is here, so for the next character it's going to appear here, so you will see. Okay, it's a top left corner of that table, and we keep print a border, another border, another upper border, and then we print the top right corner of that table, and then we start a new line. The printf right now is here. Then we print it a left border of that table. Then we print 32. It's a space. Okay. Then let's do it. 67 is the capital C. So we're going to have the C. Then we another border as a left border for the second column. Then we go 200. it's a bottom left corner for that table. Then 200.05 is another border. We're using the border for the lower part of that table. Then we close that table here. You could see the 188 is the bottom right corner of it. So now we have all the code executed. You already see the result. This is what's happening in between. Anyway, you will see for each of the characters here, it has been associated with a number. So you can, with that number, you can to print it out that character with that number. So this is what's happening in between, and this is the first example we have. So actually, when you're I'm doing it, and as I mentioned, it's a tedious work, and because you have to repeat to type in numbers. The reason I can do it is because I already have it prepared here, and I can just copy the number back to the program. It will be easier. However, in some cases, and we can write each of those as use a char to store that character. For example, we can store the music as the 14 and the play button as 16, and this will be much easier for us to know that what we are doing. We're printing out music button. Maybe we can use the new 9 and as 10. You can also do this actually. Let me just do this, easier to understand. And in that case, I can change all the new 9 here. It will be much easier for us to read the program. Here we know here output. I'm printing a music button, play button, and I start a new 9, and let's check out the result. It's just the same as we had previously, and you can do this by using more. Let me just copy the program already prepared, and it's just see here. You can previously we're using 200.01 as the top left corner, so we can declare a character for them here. And for the horizontal border, we can the number is 200.05, so we can use another char store that. In that way, we can, when we're doing the printing printf, we can just use that character, because that's they are with names, much easier to read and write, so it will be much easier than for us. And so let's run the program. It's going to give you the same result as we had in previous example. So anyway, you will see that char is that specific data type to store those values for characters. They are just numbers. However, for some reason, for the computer to be easier to recognize, they are associated with number, and the printf can check out the association between them with the mapping table called ASCII there to print characters. Okay, that's it. Let's move to another example. Okay, this is easier to read. However, you will see that every time we have to do it one character by character. This is also a lot of tedious work happening there in between. Even it's much easier to read. Actually, we can use the strings to do exactly the same thing. For example, we can declare for the I'm going to do it with the first row. Let's call it header, and we can use string. As I mentioned in the lecture, the strings are just a collection of chars. So a string can be initialized this way. It's the same like using another strings. And so in that case, I don't have to type another code like this. I can use the printf to print our string, and header, and the code will be much more compact and easier. Yes, that's it. You have the result. And actually, if you already have it stored as a char variable, you can put it this way. So this will be easier to understand. I know that I'm going to print out a music button, then a play button there. Okay, you can do the same with those by combining them into a string, and then you can use a string and printf string %s to print them out. Let me just load the code I already prepared. Oh, this is not okay. I lost that code, I guess. Sorry for that. Let me check out if I have the code or not. Example 2 or 3. Oh no. I just got too many examples there in between. Probably this one. Okay, yes it is. Okay, so you will see this is example of the source code as shown here. I'm combining each those chars into strings, like I'm initialize them with this as the first row, the second row, and third row. You can initialize them with character like this. I'm using space directly rather than using 32. I'm using the C. This is easier for a human to read. And also, if you like, you can use the number as well. So like what I'm doing for the last row. And also you can use the char variable to do it. And this is much easier to read. For example, we could see here for the first row, I'm printing out the top left corner, then horizontal border, horizontal border, horizontal border. Then I'm printing out the top right color of the table. If you check it out, and this is much easier for each of the rows, you can just use printf to do it rather than you have to repeat those again and again. That's a tedious work. So let's check it out, the result. Okay, you're going to have the same result as shown here. Okay, this is the one we're using a string. We're using strings as the collection of chars. It will be easier to read and write the program. Okay, in that case, let's move to. However, in most of the cases, we need string to save or process tests. I think that's the main reason we're having the strings. So I'm going to show you another example, um, other examples for that, and this is one. um, I'm just load the program I had already. I think that will be easier and for you and for me. So here I have declare two strings. One is I'm using the test to initialize that string directly, and it's the most intuitive way to initialize a string. However, at the second string, I'm using the initializing character by character like this. And this will help you understand that a string is indeed a collection of chars, a collection of characters. So basically, these two are equivalent, and we can check out the content of them. For these two lines of code, I'm printing them out on the screen. You will see that the message 1 and the message 2 are actually exactly the same. And for then here I have used a loop to visit each of the member chars of the message 1 and message 2, and you will see that actually every component, every member chars are the same. I mean, for the message 1 and the message 2, from there you will see that I'm printing them out, each of them as a char, as a character here. The parameter, the value I'm using is the message I, because this I is changing from 0 to the length of that message. So let's check out that result, and you will see that message 1 and message 2 are exactly the same. They're with the same content. Welcome to camp 1011. And by visiting each of the elementary char, you will see they are exactly the same. This is the third one, the fourth one, and check others, the same as space. Okay, that's it. So you will see from this example, they are actually the same strings, these two messages. Even you're initializing them in different way. Okay. However, this is just to for you to understand how the strings are composed of. But in most of the cases, we have to analyze that string. That means we have to check each of the elements. For example, here we're trying to count how many letters are in this string. Let me count how many letters, how many characters are in the message 1. That means here. So we can use reuse this loop. However, we need to set a counter. Let's call it char counter. You can use any name you like. Char counter initialize with 0, and we use another upper with 0, and to count how many characters are in upper cases. So similarly, we have the lower, and then we have digits, and then we have spaces. Those are all counters, and we can, every time we're entering there, because it's a char, so we increase the counter of chars by 1. So in this case, after this loop, this char counter will tell us how many chars or characters are in message 1, and also we can check each of the element, that means the message I, to see if they are equal to a space. If they are equal to a space, then we increases the counter for space using space plus plus, and also we can check if it's upper, it's in uppercase by using in this one. If you go back to the ASCII table, you will understand. Let's go back later and I'll show you why we can do this. Then upper. Okay, after I increase the upper by 1 in this case. Okay, let's go back to see what we're doing here. We're checking that if the value message I is larger or equal to this character A, and the message I is, oh sorry, I should do something like less than or equal to Z. This is going to give us the upper cases increased by 1 because it's going to be characters in the uppercase. Let's go back to the ASCII table. You will understand why I'm doing this. Okay, let's look at those are you could see from here, starting from 65, we could find this all uppercases from A to Z. So there are number in that range of 67 to 90. So if current value of message I is between that value, this is equal to C, is equal to say that this is equivalent to this. So they are just the same. Let me put it's the same to do the upper. However, if you put the character there, it will be easier to read, to write and read and to understand. Let me do the same for the lower cases. So it's going to, if you are checking out that table, you will understand what I'm doing. So I am going to increase the lower cases by 1 in this case, and also I'm going to do that for digits. In that case, I can copy them here. Sorry, change that to digits. So in this case, digits will be increased by 1. You will see here the character for digits are stored in the range of 48 and 57. So that's why this code can count how many digits we have there. Then we could print out the message 1. Let's use a table, and there are a number of spaces. Let's use a space holder. Number of upper and also number of lower and number of digits, and we're going to give them parameters as and spaces, then upper, then lower, and digits. I guess that's all of it. Okay, let's end that. So this is going to give us the results. Let's go to see what happened. What's going to happen? You will see that here in message 1 we're having 3 spaces. It's 1, 2, 3. Yes, that's right. And for the uppercases, there are 5 of them. W, C, O, M, P. There are uppercases. Lowercases, we have 8 digits. We have 4 here. Okay, it's all correct. Okay, then this is actually our checking if they are in that range. Let me just change them back to A and Z. As I mentioned, they are just equivalent to each other, and if you're going to run that, you have the same results. Okay, what's happening here is within this loop we're actually checking the value by comparing them to each of. For example, right now the message I, because I equal to 0, so right now it's equal to W. If we move to the next line, we're going to see it's going to be an uppercases character. So the upper right now equals to 0. After we increase by 1, it's equal to 1. Okay, then we get in that loop to check the second char in that message 1. It's going to be W. So W is no, sorry, it's E. The lowercase is E. So in that case, we're going to get into the lowercase A. Right now it's 0. After execution, it's 1. So let's move the gain. Right now we're at the L. L is a lowercase, so it's going to be into this if condition, and right now it's equal to 2. So right now we're here, so it's going to repeat again and again. So we have in that case we're going to have what we want. This is what this code is doing. Let's get to that code. Okay, you're going to have that result shown here. We already had it. Right now it's the same. However, sometime previously we actually have shown one typical application of using the strings and to analyze the strings. We're to use to do statistics on strings. This is one of the typical tasks for process the tests. And sometimes we rather than doing the statistics, we need to process the string. For example, we can convert the message to all upper cases. I mean, to transform those lower cases to upper cases with that loop. So in this case, we can do something like we can add a new loop here. Then right now we're doing it with the message 2. So let's copy that condition with the test statement, because this is going to check if it's lower cases or not. Then let's do it for message 2. If it's a character in lower cases, we can change its value to upper cases. However, how can we do it? Here we can use its current value, that means message 2i, to subtract the character A. The character A here is a number. So what we are doing here is, if you go back to go back to the ASCII table, you will understand why we're doing this. By subtract the current value of the message to I with the A, that means we are subtract number 97. It's going to tell you that how far it is from the 97, and then this will tell you its index in the alphabet table. So in that case, we can use that index by adding uppercases A. For example, it's going to transfer the lower cases character to uppercases. So what's happening here? Let me give you one example. For example, we have lower cases E, and right now it's the value should be 101. So by subtracting that to 97, we know the index of that lowercase a in the alphabet. Then we it's going to be something like 1, like 1, 2, 3, 4. So lower cases, after the subtracting, you're going to have 4 as the index for E. So then by this is the result. If the message to I equals to the lower cases E, you're going to have a 4 here. Then we can add them back to the number of uppercases A. That means in this table it's 90, it's 65. So by adding 4 on it, we're going to have 1, 2, 3, 4. That's exactly the number for the uppercases E. In that case, we're transferring lowercases character to its uppercases. So we can print out the message 2, and remember it's a modified message 2 as this as message 2. So you will see that the content has already been changed after this. Okay, here's the result. You will see the modified message 2 is going to be all uppercases. The E has been transferred to uppercases. The L has been changed to uppercases. C to here, and all of them, all the lower cases character has been changed to its uppercases form in this string. Okay, we can actually, to observe the result, we can do something like this. And let's just define a char as C, so we can see what's happening there. Let's make C equals to message 2 there. Then here we can use the C rather than this one. In that case, we're going to change that to C, and also we are changing the message to C. This will modify the content as well. So by doing this, we can actually set a breakpoint there to observe what's the current value and what's happening in between by using debugging. So right now we will see sorry, I'm doing something wrong. This here should be I rather than 2. So let's go here. So right now you will see I right now equal to 0. That means we are at the W. Let's move to next line. So see, right now it's uppercases W because it's not a lower cases. It's going to escape the if condition. Then right now we have the second character as the E. Then it's a lower cases. It's going to enter the if condition, the statement. So by doing the subtracting, then addition, the value will be changed to uppercases E. Right now you have seen here. Then we set that value back to the message 2 I. Then the content of the message 2 will be changed. Then right now we're at the third elementary chars. It should be the lowercase L. So this is what we are going to have. Then it will enter there to do the subtracting and addition. Then this lowercase L will be changed to uppercase L, and we are setting them back to the string. So by repeating this, we're going to have the final results as we expected, which has changed all the lowercase character to the uppercases. Okay, this is what's happening by processing the strings. This is another example. Okay, this is what I'm going to demonstrate today. You can follow the video by typing in those examples by yourself. I think you can learn through examples much easier. Okay, thank you. That's all of it. Bye bye.